We'll solve problem 16 of chapter 6. It is based on the electromagnetic induction, magnetic field, mutual induction, and the EMF generated. Let us do the part A first. In part A, we have to find what is the mutual inductance between this coil or loop and this wire. We know that when a wire carries current, suppose it is given it is carrying current in this direction, by right hand thumb rule you will get the circular loops of the magnetic field, and you can see these are, depending upon the location, you have the loops, and in fact the magnetic field lines will hit perpendicular normal to this surface by the geometry. And let us take any distance x and let the width of the strip be dx. We know that the magnetic field around the coil carrying current is given by mu 0 I upon twice pi x. Let this be x0 so that we don't get confused between x and x0. In the book it is given x, let us take it as x0 and take this variable as x. This we have taken as x. Now the flux which is passing through this small strip, due to the magnetic field, the magnetic flux will be mu 0 I upon twice pi x into a dx is the flux through the small strip. Now what is the total flux? Total flux would be integral of, this is constant, mu 0 I upon twice pi is constant, a is constant, and dx upon x, which we get phi b total is mu 0 I upon twice pi into a, this is constant and this is log x, and the limit is from x0 to x0 plus a. The outer distance is x0 plus a. So let us put the limits x0 to x0 plus a. So we get the result as mu 0 I a upon twice pi ln log x0 plus a upon x0 is the flux. Now we know the relationship between the flux and the mutual inductance. If we write phi 1 is equal to m1 to I2, if I2 is this current flowing through this wire, the flux between 1 and 2, if this is 1, so the flux between 1 and 2 is given by this relationship. So we know what is the flux through 1 is this is phi 1, which would be equal to m1 to I2 is I is equal to mu 0 IA upon twice pi ln x0 plus x upon x0. I gets cancelled, so we get the mutual inductance as mu 0 A upon twice pi ln x0 plus a, sorry this is a, upon x0 is the mutual inductance. That is the answer of part 1. Now going to the part 2, we have to find the EMF, which would be minus d phi b upon dt. That is differential of flux with respect to time. So we get minus mu 0 I a upon twice pi, and this becomes x0 upon x0 plus a, and it becomes minus a upon x0 square into dx0 upon dt. This is nothing but the velocity. Here x0 we have taken as variable. It is not constant here. This is variable. Now put the values and we get the answer mu 0 I upon, make it 4 pi multiplied by 2 into a, this is x0 upon x0 plus a, minus sign has got cancelled, a upon x0 square, so we cancel it, and this is the velocity. Velocity is given as 10. Let us put the value 2 into 10 to power minus 7. Current is 50. A is zero point 0.1 into zero point 0.1 upon x0 plus a is zero point 0.3 into 1 upon zero point 0.2. So this comes to, this gets, point gets cancelled. We get the result as 100 into 10 to power minus 7 divided by 6 into, this was 10 into velocity was 10 into 10. So we get 10 upon 6 is about 1.67, and this become 10 to power minus 5 is the EMF in volt. So this is the answer.